Find the equation of an exponential function when the initial value is not known. So these can be a little tricky. So first of all, exponential function. We've got f of x equals ab to the x, where a is the initial amount or the initial value. What do we start with? B is going to be our growth or our decay factor, depending on the problem. We do know that B is always going to be greater than 0, but B cannot be equal to 1. If it's only 1, we are neither growing nor decaying. Okay, so if B is between 0 and 1, it's decay. And if B is greater than 1, then we are growth. Just kind of an FYI there. Okay, so how do we find the equation given 2 points? So first, we're going to substitute into that f of x equals ab to the x equation, each point in, because our point will give us x and y. Then we can solve those equations, the system, to find a and b. Once we have a and b, we plug them back into that function, and now we have ourselves our exponential equation. It sounds a little more difficult than it really is when you put it that way. So let's walk through 2 examples. So write the exponential function that falls through the points 1/6 and 2/18. Okay, so first of all, we have xy, xy. So if I think about f of x equals a times b to the x, remember, f of x is the same as y. So let's plug in what we know. I know that 6 equals a times b to the first power. And I know that 18 equals a times b to the second power. And at this point, if you're thinking, Becky, this looks real hard, don't worry, stay with me here. Okay, so that's step 1. Step 2, notice in our first equation, we have b to the first power. That's important. That's going to make our life a little easier. In both equations, we have a basic a. So because a has the same exponent in both sides, a is what we want to get by itself. So here in the first equation, to get a by itself, I'm going to divide both sides by b, because b over b is just 1. So I end up with a equals 6 over b. If a is the same as 6 over b, then I can take this 6 over b and substitute it into the second equation. So that would give me 18 equals 6 over b times b squared, right? The substitution piece, a, so I can substitute in an equal statement here. Now, to solve this, think about this b squared. If I have b squared, that's the same as b squared over 1, right? Any whole number is just over 1 as a fraction. So this is like b to the first, b to the second. Well, I can reduce. Let me break it down for you. B squared is the same as b over b, and in the bottom I just have b. That means this b will cancel out one of those b's, and I have just one b remaining. So when those cancel out, I'm left with one b. So I have 18 equals 6 times b. Okay, I hope that made sense. So if 18 equals 6b, divide both sides by 6, that means b has a value of 3. Well, let's go back to this equation. That means a equals 6 divided by 3. That means a is 2. So now I can write my function f of x equals 2 times 3 to the x. And that's the idea, okay? I know it can be a little tricky, so let's do another one. Write an exponential function through 1, negative 12, and 0, negative 3. So in this one, I threw in some negatives for you as well. But remember, we have xy, xy. Okay, so my first one. Oh, sorry. Goodness gracious. Okay, so our function is f of x equals a times b to the x. All right, so I've got function 1. Let's deal with this one first. Y equals a times b to the x. And then this one, y equals a times b to the x. Now, hopefully you have bells ringing in your head right now, not in a bad way. But knowing what is b to the 0? Well, anything to the 0 power is 1. So this equation is really negative 3 equals a times 1, which is just a equals negative 3. So if a is negative 3, well, I just take that, plug it in up here. So negative 12 equals negative 3 times b to the first. Divide both sides by negative 3, and b equals 4. So that makes my function f of x equals a times b to the x. So that one was just a little bit different, but I wanted you to have examples both different ways to see how you can write an equation of an exponential function when you're not given your initial value. And actually, in this case, we were given an initial value, but you were given it in an ordered pair, not as, hey, this is what we're starting with. So it's good to know.